Hi, this is Greg Johnson. I'm former president and past board member for the Manufacturers Standardization Society. What we have here is a presentation that covers the long history of MSS and how it's tied into the birth and growth of the valve and fittings industry in the United States. We're talking about MSS today and the history of MSS, but we can't really talk about MSS without talking about the history of valves in the United States and the broad scope of history that is tied with MSS. So let's get started right now. The industry, the valve industry primarily, began in the mid-1800s, and this was coincident with the Industrial Revolution. And most of the major manufacturers in the United States, which were also members and became members later on of MSS, they were founded in this period from 1845 to 1870. A lot of them started as manufacturers of boilers, and they needed valves for their boilers, so they just started making their own. And eventually it became an individual industry where the valves were actually made by manufacturer. One of the issues was each manufacturer had their own design. Everything was different. They were different lengths. They were different sizes. The threads were different. Nothing was interchangeable at all. So it made it difficult if you bought a boiler from manufacturer A and then you wanted to add on to it or do something different, nothing fit. So there was a real need for standardization. It was actually slowing down the growth of the Industrial Revolution. Looking at a couple of patents here, these were two of the major manufacturers, Frederick Lunkenheimer on the left and Powell on the right. These were their first patents that they achieved. The one on the left, 1865. The one on the right is 1868. So things were starting to roll at this point, to the point where these folks wanted to patent their designs. Again, though, nothing is standard. The threads, nothing. So they are growing fast. They're doing a good job of marketing, but nothing works together very well. This is one of the large manufacturers, picture of their plant during the time. You can see it's probably spread out over 30 acres or so. And looking on the right there, we see a Scientific American from the 1800s. 1880s, and you can see the cuts of the illustrations showing the inside of their plant right there. And the scope is just really growing of the whole industry because of, again, it's all driven by the steam power, steam engines, steam is running everything, locomotives, steamboats, but probably bigger still, it's running also the individual plants and providing energy to run all the individual plants. But there's problems happening at this point. Everybody's working fast. They're making these things, and they're doing the best they can in most cases, but they're not really experienced enough to understand what's happening to the materials and some of their designs. So there's a spate of boiler explosion. The worst ones, this was the worst one, the Sultana explosion. It was 1865, and over 1,000 people were killed because the boiler blew up inside the steamboat. So a group of insurance people got together with manufacturers, and they created a company called the Hartford Steam Boiler Company. And they were an insurance company. They were insuring the boilers and the facilities in which the boilers were located. And as an adjunct to that, the American Society of Mechanical Engineers was created in 1880 to also try to work on these problems. They developed a boiler testing standard in 1884 and a pipe thread standard in 1885. So that was a good start right there. They could at least standardize the testing of these boilers, which did contain a lot of valves. And they were able to thread other pieces of equipment to them because they standardized the threads. But still, the problem was not completely solved on the boiler side. There were still explosions and still issues with that. And it wouldn't be until 1914 before the American Society of Mechanical Engineers created the Boiler and Pressure Vessel Code in 1914. It was very good for boilers directly, but it didn't do much for valves. There was the only thing covered in the original Boiler and Pressure Vessel Code were relief valves, pressure relief valves. And if you look on the top of this boiler, you see a lever with a round ball hanging from it, and that's the relief valve for the boiler. As the pressure built up, it would pop off and keep the boiler from exploding. So that was a start, but it didn't cover valves in great detail at all. But it was boom times. You can see here in these pictures that range from 1908 up through the late 20s and early 30s. Everybody is focused, and there's a lot of manufacturing going on. There's some standardization in manufacturing by manufacturer, although not industry. Looking at the top picture up there, you can see the women are in the background, and they're assembling and testing the smaller valves, and while the gentlemen in the front are working on the larger, heavier valves. And looking at the picture on the left, kind of looks like a little valve you would see in a big box store made out of bronze. Only this valve is a 20-inch valve, meaning that 20-inch diameter pipe is to attach to it. But what's really unusual is these flat spots on there are normally designed for wrenches. Well, that's got to be one of the world's largest wrenches on there. But this was a threaded valve, a 20-inch threaded valve. Very difficult to thread the pipe in there. And maybe they did have a giant wrench, I don't know, but was unusual. And about this time, the manufacturers they were kind of up to their necks in problems here because there were so many manufacturers, and they were selling, and one manufacturer would get part of a job, another would get a different part of the job, but nothing was fitting together because there was no standardization. So the manufacturers, a group of them, started what was called the Valve and Fitting Institute in 1898, and it ran until about 1910. Didn't get a lot of traction. Then they changed the name and the scope a bit, and the new organization was the Committee of Manufacturers on Standardization of Fittings and Flanges, or Valves, rather. That was 1911, 1913. Then another change was the Valve and Fitting Manufacturers Association in 1914. And most of this work was directed by some of the very large manufacturers, in this case, particularly the Crane Company and the Walworth Company. Crane, by the way, would be the largest valve manufacturer for nearly 100 years. So they were making some traction here. They started the organization, and it was gaining traction. The first document created by this group, which would later become the MSS Manufacturer Standardization Society, their first product, as it was a flange standard for extra heavy companion flanges. And what that means is these flanges, you see, they had threads on the inside, and they were to be threaded onto pipe, and the pipe would then have flange on the end so it could be assembled and disassembled. And these the dimensions for these flanges are very close to one of our sizes and pressure classes today, which is class 300 in the ASME, American Society of Mechanical Engineers, B16.5 document. So now that we've got a start here, we've got some flanges. Everybody knows what size they're supposed to be, what size the bolt holes are supposed to be, and it was a good start. There's still no official organization that's handling all this. These these dimensions were usually provided by each manufacturer on their letterhead and sent out, and they were made free of charge. Didn't have to worry about paying for them. They were used as a marketing tool. Well, World War I started changing things, and they really put the focus, or the war really put the focus on standardization. The War Industries Board and the Emergency Fleet Corporation, those folks were involved with the production of merchant ships and Navy ships. And there was a big issue because now you've got all of these different manufacturers and they're making products. They're all going on the same ships. And one end of the pipe coming from a boiler and maybe going to a pump, it's not the same on the other end. So it really did complicate things as far as manufacture ships. But there would be a lot learned from World War I, and all these steps and procedures and policies would come in very handy in World War II when the arsenal of democracy was put into place. 1924, finally, the Manufacturers Standardization Society of the Valve and Fittings Industry becomes reality. They were also a charter member of the American Standards Association, ASA, which was the largest standard association in the country at the time. And they created one of their first documents, didn't even have an MSS number, but it became part of a very, very common American Society of Mechanical Engineers document, B31.3, a piping document. And it wasn't just that one ASME document. They also were involved in providing the data and the all of the verbiage that went into many of the original B16 documents, which are the design documents as a whole that are used for designing valves and a number of other things. Steam is still driving the industry. It is a steam industry. That's where most of the money is made, although water, they're making a lot of valves for water as well. But the bigger, higher pressure valves are all utilized at this point for the steam industry, and designs and requirements all come from that industry. On the left, we see a familiar face. That's Thomas Edison, and he's at the 1922 electrical show, and he is opening this valve. I guess it's symbolically making something happen at the generator station somewhere, but it does show the importance of valves and generation of electricity. On the right is a typical steam engine, and you can see it right there. There's a big pipe in the middle in the back, and that comes from the boiler. And there's a very large valve back there, a gate valve back there. And looking at the handle design, it's made by the Chapman Company. So that steam is coming in and it's powering this big engine right here, which the piston moves back and forth, and there's a very large flywheel on the right. Steam is driving the industry. One thing that happened during this time that was very important was the creation of pressure ratings. And MSS, while they weren't the actual hosting body for this particular standard, they did most of the work. And it was published by ASA in 1927. And what this did, this actually created pressure ratings and classes for these pressure ratings. And as you can see, except for the 150, they were all based on 750 degrees operating pressure of steam. The 150 was an outlier, and it was designed primarily for some of the transportation boilers, such as on steam locomotives. This is a list of just some of the MSS standard practices that were adopted by ASTM and ASA, which also was ASME at this point. You can see on the right, there's a number of them, some of them very important. To me, the most important on the page is the SP66 down at the bottom, and we'll talk about it later, but that was in 1965. So MSS worked very closely with other organizations, and we weren't too proud to, we were very proud of our work, but we weren't too proud to share that work with a larger standards body or organization that had a bigger footprint. Business is really booming now. We're in the primarily the 20s, and you can see on the left, this was the Crane Company in Chicago. This plant was an integrated plant on 67 acres up on the southwest side of Chicago. They had all their own foundries in there. They made their own steel and bronze and iron. The middle building was the plant administration building, had a beautiful clock tower on the top. Problem with all of this was, first of all, it was very valuable real estate later on, but also, as many other buildings in that period of time, it was full of asbestos. So by the late 60s, 1970s, the latest, it was torn down. Everything is gone on that. That was the manufacturing part of this particular company. But if you look in the middle there, the 888, that was the address on Michigan Avenue in Chicago for the Crane Company. And if you walked in the door, that picture in the bottom is what you saw. This gigantic 84-inch valve was sitting right in the middle of the lobby, and you walked around it on the stairs to get up to the different levels. Marketing was also a big deal during this time. The companies were flush with money, so they built showrooms in major areas of the country. The one on the right, with the gentleman standing in the middle of the valve, this was the Crane showroom on the Atlantic City Boardwalk. And this valve was actuated by electric motors. You can see them up there on the top. And I have a video of this opening and closing, but this was a very expensive entrance into their showroom in Atlantic City. But things don't always stay at the top, and business is not always growing every year. The Depression hit, and it had a very strong effect on the valve and fitting industry, like it did on every other industry. During that period of the 20s, one MSS meeting was canceled, and they didn't really produce a lot of standards, only 18 for the 10-year period, although 3 of them were very important. You can see them there, SP6, SP9, and SP25, SP25 being the most important standard marking systems for valves, which now you could at least look on the valve and you could compare it to another valve of another manufacturer and know that the information was going to be on there, was a requirement. So we're going through this depressed period, which really slowed all industry down. But there was a light at the end of the tunnel. Unfortunately, it was Europe and Asia that were burning. Right before the Japanese bombed Pearl Harbor, the United States began working in earnest to build up their arsenal of democracy starting in about 1940. Production priorities were all focused on defense, and that included items such as shipbuilding and things of this nature. During the war period, production had to be regulated and controlled because we had, in the case of the valve business, you had all these manufacturers and they were making everything. Every manufacturer seemed to make every type and material of valve. But what the War Production Board needed, they needed lean production. And so what they did was they established rules which restricted manufacturers. They would pick manufacturer A and say, you're going to make steel valves of this size. Manufacturer B, you're going to make iron valves of this size. So there was controls on there, and even some sizes were even temporarily suspended. They weren't allowed to be made. Although the Navy still had some very unusual sizes, 3.5, 7, and 9, because they had ships that were in service that had been built from the turn of the century up through about 1915, and they had some of these odd pipe sizes in there. This is a catalog from the period, and you can see it's got the big X's marked out. Rather than redo every single page, what some of the manufacturers did was they just X'd out this information, and it's essentially this is what this manufacturer was not allowed to make. So you can see in this case, this particular product line, there was no way that they could manufacture that because they were supposed to be, in this case, maybe steel valves of different pressures and materials. The war also created a lot of opportunities for valve and fitting manufacturers. This is just one particular case. What you see over there is a letter, and this is from the War Production Board, and essentially it is an initial purchase order for 100 sets of these valves to go in a number of ships. In this case, these were probably Liberty ships based on the quantity. So this would be like the initial letter. And if you're a manufacturer, this is great because this is good business. It's good repeat business, and you're in the production line business, so it's the kind of thing that you can make money on. And a lot of the manufacturers did very well during this period. This is just kind of a close-up of that particular inquiry and purchase order. You can see right there, your proposal is acceptable for 100 ships. That is a lot of valves, and that's a lot of money. And they were really pumping things out because you can see delivery of 4 to 5 weeks. The picture on the bottom, this is the company where this work was performed. This is the Stockham Company in Birmingham, Alabama. This is their foundries are located here on the bottom of the picture, bronze and iron foundries. So they did very well, as did most all of the manufacturers of valves. In fact, there was so much valve work to be done. Many companies began during this period, and a lot of companies manufactured valves that had never manufactured them before because the need was so great. So again, it was good business. This is a warehouse out in Northern California, and what you see on the left is a typical Liberty ship. These were ships that were designed to last 5 to 10 years, and they would help us provide materials and get them overseas very rapidly. And you see on the right, these are a number of what's called ship sets, and this would be all the valves that would be used on one particular ship. This is probably a number of ship sets. That's a tough one to say. Ship sets, you can see over there in the warehouse. So again, this is big business, and it's very profitable business, but it's very focused because the manufacturers couldn't really expand their product lines. They had to make what they were told to make by the War Products Administration and the different boards and groups. Another industry that was created during this time was the pipeline industry. In the early part of the war, 1942, the first 6 months especially, this is after the U.S. was in the war and Germany had declared war on the United States. U-boat submarine activity was sinking many of the tankers that were bringing oil and gasoline from the Gulf Coast up to the Northeast, Philadelphia, Boston, New York, and that area. So what we needed was pipelines plural. So initially they created what was called the Big Inch. It was very famous, and it ran from East Texas up to New York with a branch that went up toward Chicago. So you can see construction on the left over there of the Big Inch pipeline will be buried there. On the right's a typical pumping station of the period, loaded with valves again. And it was good business, and it really kicked off the pipeline industry in the United States. Okay, the war is over, and now the peace begins, and it's time to get back to work. You've got lots and lots of men coming home, and they need jobs. There's concern of recession as the industry of the United States switches from a wartime industry very restrictive to a wide open peacetime industry. And during this particular time, during the war years, MSS really just concentrated on simplification and production. Really, not a lot of MSS standards were published, actually only 3. And these were eventually incorporated into other standards. Well, actually, one of them was withdrawn. So MSS was busy helping to win the war and not doing a lot of standards creation during World War II. But it was a huge boon to the industry. New materials were created, and the one we're going to talk about in just a minute is Teflon. New industries were also created, such as the nuclear industry, and that would be a very big one. Valve designs, there were new designs created. As a result of the Teflon, the ball valve industry would be able to take off, and that happened in the 50s. And then we also had the pressure seal design, which was very effective in saving material. But another thing, a result of the war, you had this manpower now, and all of these young men, they started out as kids and 17, 18 years old, and they went through the war, and they brought a new attitude back to the workplace. They had a maturity, and they were more serious. So you had a better workforce, which really helped in focusing on production and working and doing the job right. The 50s. Lots of business, lots of standards were written. MSS was very busy creating some very important standards, some of which, actually in this particular list, most of which came and was passed on to ASME in the B16 side. But these were very important standards. A few are still there and monitored by MSS today. But most of these, while very important, were, again, passed off to another standards organization. At this time, going into the 50s, with the nuclear business and its footprint, we needed some standards that address quality. And we created in MSS 3 of the longest standing standards. They're still published today, and they're still very, very effective. One was for magnetic particle examination, which is what you see on the upper right. I'm sorry, that's radiography. The one in the bottom right is magnetic particle. And another one was for radiography. And a third one was a visual inspection of the surface condition of the material. So these were very, very important. And they came out of the requirements for the nuclear industry, which was becoming very important in the U.S. Rickover's nuclear navy, which also the nuclear part of it came out of World War II in the Manhattan Project. The nuclear navy had very, very special valve requirements. And Hyman Rickover was a stickler for detail and quality. And a lot of this, again, actually bled over into standards and specification for the overall valve business. The big project initially was the USS Nautilus, and again, that was kind of the test bed for nuclear navy and nuclear-powered ships. But this morphed fairly seamlessly into nuclear power plant construction. The Shippensburg, Pennsylvania power plant was the first one constructed, and a lot of the initial work was taken up by Rickover's group of people. In order to provide valves for the nuclear applications, ASME created what was called a N-stamp, and this was very, very detailed specification and procedures, and you had to be audited in order to get this stamp, and you had to have the stamp to make a nuclear valve. So that was a very big deal. Probably a half a dozen of the larger major manufacturers during this period had N-stamps, and they were involved in the nuclear industry. For a long time, going back to the mid-30s, the industry had been trying to create a standard for testing valves. And you think, well, that should be very easy, but they just could not get agreement from it. A VMA technical committee worked on it during World War II, and you would have thought for the goal of winning the war, perhaps they could come to some agreement and create a document. What the problem was, they could not agree on leakage rates. That was the problem. And finally, after 27 years of cussing and discussing this issue, MSS published the first valve testing standard, SP61, and this was in 1961. 7 years later, the American Petroleum Institute would follow with their testing standard, which was API 598, which would eventually take some of the load from the SP61 standard, although it is still used a lot today. Oh, the Great Teflon War. This was the birth of the ball valve. And Teflon was invented by DuPont as a part of the Manhattan Project, and it was an accidental development. They were trying to do something else, but they created this material, which today is being discussed a lot because of PFAS, which is a material that's not good on the body, and we're trying to ensure that that does not go into the valves and fittings and pipes that are being made today. But anyway, here is the initial birth of the ball valve, which is a huge player in the industry today. Looking on the left, you can say, well, 1871, that was the first ball valve that was patented. That's true, but it was a metal design, and every time you opened it, you scratched the ball. So it was not so good and didn't last long and was not utilized. The one in the middle was designed in 1942. That's when they filed the patent. And this was the Crane Company in Chicago. And they just kind of sat on this for a while. I had a friend who was in the engineering department during this time, and they had a meeting discussing this particular design. This was probably early 50s, 52, something like that. And they said they could see no commercial advantage of creating a ball valve like this. So they decided not to manufacture. Big mistake. However, this was just before Teflon was first used in valves. The initial patent for this was granted to Howard Freeman. You can see that on the right. Again, this initially, the very first one did not have Teflon for the seats, but it did not take long for Mr. Freeman, who worked for the Rockwood Sprinkler Company, to utilize Teflon in the seats here. You can see the red parts on the left and the DuPont down at the bottom. Rockwood Sprinkler and Howard Freeman did a lot of work for the government. In fact, he invented the fogging adapter that went on hoses to put out fires on ships. So he was involved in valve construction and design. And with his connections in the Department of War at that point, it wasn't the Department of Defense yet, he got wind of the Teflon product, and he was the first manufacturer to utilize that. His initial design had rubber seats, but the Teflon became the de facto standard for that. He left and formed the James Berry Company, and then everybody started using Teflon seats. Everybody was suing everybody, all of the ball valve manufacturers initially, and it wasn't until 1988 that all these suits were settled. But it was a huge, huge event in the history of valves, and MSS was right in there providing standards for that. One of the most important standards that MSS did create was SP66. And until butt weld in valves, which are like those on the right, which are designed to be welded into a piece of pipe as opposed to bolted. Until that point, the method for rating the valve pressure was based on a flange standard, ASA B16.5. But as the pressures in the steam service and refining services rose, it was requiring valves with gigantic flanges on the bodies and the bonnets and the ends. So the pressure seal valve was designed. The problem was there was no way to rate the pressures that it would handle. So a group of MSS engineers worked on this, and they created a standard that was based on the mechanical properties of the material, and that was MSS SP66, which eventually would become the ASME B1634, which is the primary design document for valves today. Another situation that arose was pollution and pollution control. Big event, 1948, was the Donora smog. This was in a suburb of Pittsburgh that had a lot of heavy industry in it. And they had a temperature inversion back in 1948 over this area. And so all of the toxic effluent and smoke couldn't go anywhere. It just rose up to the cloud cover, which was about 2,000 or 3,000 feet. And it was so bad that 20 people were killed and thousands were actually made sick by this. So this got the attention of the government and manufacturing and people all over the United States, and it eventually would result in the creation of the Clean Air Act and other organizations that were fighting for clean air. Also, what came out of a little bit later time frame, going late 1980s, they're concerned about fugitive emissions and air quality. But what happens also with that problem, it's a double whammy. Asbestos becomes a very big target because the same properties that made asbestos a very good sealing material also made it very likely to the fibers rest in the lungs of people that were around that. So by 1990, there was a requirement for not only control of these fugitive emissions, but we had to use completely new material. So that was going to require new standards and specifications. MSS was the first organization to create those specifications with SP120, and this was flexible graphite systems for rising stem valves. Essentially, it was a standard for graphite type packings, and it enabled everybody to standardize and also kind of up the quality of all of these particular seals. MSS followed that up with SP121, and this was a way to qualify the actual material. You simulated a service situation and heated the fixture up and ran it back and forth. The data and the information, basically the skeleton of SP121, became API 622, which is the de facto standard for fugitive emissions testing today. Another solution that was proposed, and a very good solution, but very expensive, it was mandated initially in California for valves under 2-inch, and eventually for all the valves out there. They required what was called the best available control technology, and the PhD from Harvard who was running this out there felt that bellow seals was the best available control technology, so they wrote the requirements in there. However, there was no standard for bellow seals. So to fill this void, MSS created a very valuable and timely standard. That was MSS SP117, bellow seals for globe and gate valves. And this was published in 1995. MSS as we got close to the turn of the century, we looked at other areas that needed standards and specifications. And MSS was approached by the pipe hanger group, said, hey, we need some standards and specifications to cover the hangers that are very important in piping and refineries and other types of industrial facilities. So we created a new Committee 403 on pipe hangers. And since their creation, they have been very, very active. They've created standards that are used worldwide, and they become one of the most important committees in MSS. Our membership has essentially mirrored the economy. When things are really bleak or depressed, we tend to lose some members. But for the last 15, 20 years, we've been on an upsurge, and we're over 120 members right now. So it's a very viable organization, and it's continued to grow as the years moved on. Meetings. Every year, MSS holds an annual meeting. And the first location was in New York. In fact, most of the initial meetings were held there, the first 40 years worth. And the hotel of choice was the Biltmore Hotel in New York. And you can see the august body there on the top in the middle. Looks like some very serious people there. A few of them did like their cigars. I imagine the smoke in that room was probably very heavy from cigarettes, cigars, and pipes. But they did meet together once a year for this major annual meeting. We still do that today. And since 1975, the meetings had been held in Florida, because most of these companies were up in the Rust Belt or in the Northeast, and it was cold there, and they wanted to get down in some warm weather. So after we did the first Florida meetings, that became very popular, and all of them have been in Florida since 75. However, this year will be the first time that we have a meeting. That this year, I say this is 2025, the first time that we'll be meeting outside of Florida. We'll be meeting in a warm spot in Arizona. Our meetings are very important, and a lot of work is accomplished. But when we set up these schedules for the meetings, our goal is to not fill 8 hours a day for 3 days with meetings. Our meetings are designed and so that the attendees have plenty of time to network and relax, and they're all encouraged to bring their spouses or their families. And you can see here some of the activities. Bottom left, this is a boat tour. On the right, this is one of our typical barbecue dinners that we have on Sunday night. But they're great for meeting folks and networking, and just a very good social activity. Some more pictures here on the right, one of our annual meetings there. And there's Olin Thornton playing his, I think it's a bouzouki. I am not sure. It's not a mandolin, though. But he was one of our executive directors. He was also a very good musician. So we're going to 100 years now of MSS, and in the 21st century, we've also had a century of really good people, smart people, people that were very much focused on doing the work of MSS, but they all come to the meeting and they were all having a good time and enjoyed the social aspect of it. This was just one of our pictures of our folks. This was probably about 10 years ago. Lots of very good engineers and technical people. I'd like to point out a few special people, though, that are no longer coming to the meetings or passed on. The first one on the left is Dave Cornelison. He was the epitome of class and professionalism. He had worked for the Woolworth Company for about 20 years and was a very calm, calculated gentleman, and always had a compromise solution for any issue that came up. Another one on the right Guy Jolly, he was a brilliant engineer. He worked for the Vote Company, and we were trying to figure out how big a bubble was, because bubbles were used to measure leakage rates. So Guy took that on, and he had a degree in engineering, but also a master's degree in mathematics. And he created a 30-page document that told you everything you wanted to know about a bubble and how big it is and how to measure it, etc. But very good engineer. Some more special folks that had been around MSS during the last 30 years or so. First, Tom Hannafin on the left. He was the number one cheerleader and promoter for MSS. He was always talking it up. In the middle, A.J. Del Buono from Wellben. I think probably 5 or 6 years ago, he got his 40-year pin for activities in MSS. And on the right, Rush McClinton. He was one of our really good engineering representatives. He worked for a couple of different manufacturers, Stockham and Milwaukee, but he had a prior career in the U.S. Corps of Engineers. He was a colonel, so he brought a lot of organizational knowledge and was another great guy who was a member of MSS. So 100 years, but we've had lots and lots of really good people that created our standards and participated in our activities. And it's been and still is a great part and an important part of the organization. Well, as we look forward to our next 100 years, our group of people are working very hard. We have a lot of new SPs that are nearing production, and as we usually do. And we've got a new committee, Committee 410, and they're focusing on application standards. They just published their first one, which is a standard for hydrofluoric acid alkylation valves, and it's very timely. It's important. It's been needed in the refining industry, and API asked if MSS could create something like that. And we said, sure, we just need to bring in some of the end users that can give us some valuable information. And this was the first use of what we call our subject matter experts. This was an expanded membership role that we now have, which allows us to bring non-manufacturers in and have them work on the committees. And this new HF alkylation standard would not have been created without the input from subject matter experts. We're also expanding our marketing and our promotion. We're working a lot closer with ISO, the International Organization for Standardization. We're now the host for that here in the United States for the U.S. group. And like I mentioned, we're also looking at some new meeting locations. But our job is creating standards, and energy especially is changing during this period. And the things that we helped make the valve history over the past 100 years, we're looking at a number of new things that are really important that we're working on. First of all, hydrogen. We have a group that's creating a standard for testing valves for hydrogen service, and it's very important. Hydrogen will be a major source of energy in the future, and there have been no hydrogen valve standards. And it looks like these standards, the first two that we are creating, one for testing cryogenically and the other for testing ambient temperature hydrogen, these should be published in 2025. We're also looking at applications such as carbon sequestration, and also some carryover into CO2 pipelines, geothermal industry. There's just a number of areas where MSS is making and helping to make history for the next 100 years, and also helping to expand the valve industry as a whole with good people coming together to create very important and very timely specifications. So The organization has made it for 100 years, and it looks like with the input of all of the great people we have in the organization, the next 100 years look pretty well for us as well. Thanks for watching the history of MSS and the U.S. valve industry. For more information on the MSS organization, please visit us at msshq.org.